everyone. In this video, I am going to discuss problem number T secret Santa from today's Codeforces contest. So let's go through the problem statement first. So basically, we are given n employees numbered from 1 to n who take part in the event. So each employee I is assigned a different employee BI to which employee I has to make a New Year gift. Okay. Each employee is assigned to exactly one other employee and nobody is assigned to themselves. But two employees may be assigned to each other. Formally, all BI must be distinct integers between 1 and n, and for any I, BI should not be equal to I. Okay. The assignment is usually generated randomly. This year, as an experiment, all event participants have been asked who they wish to make a gift to. Each employee I has said that they wish to make a gift to employee AI. Now we have to find a valid assignment B that maximizes the number of fulfilled wishes of the employees. Okay, so let's understand uh, what we have to do with this example. Okay, so basically here we have 7 employees and numbered from 1 to up to 7, and this value AI is representing what the ith employee, the person whom ith employee wishes to give a gift. So for the first employee wishes to give a gift to employee number 6, the second employee wishes to gift employee number 4, the third employee wishes to gift employee number 6, fourth to 2, and so on. So what we have to do is basically we have to finally output an array which represent that ith person is going to gift this bi person. So since each employee is going to gift one and only and unique another employee, so all these numbers are going to be between 1 and n. Okay, so if this is, if you can see here, person number 1, employee number 1, 3 and 6, sorry, 1, 3 and 7, these three employees are willing to gift employee number 6, but only one of them can be assigned 6 because all these BIs should be unique. So we can we can assign only one person uh, among them to give to person number 6. So like that we can assign only one person to 2, we can assign only one person to 4. So number of unique employees among this array are going to be maximum number of employees whom we can uh, assign such that their wish gets fulfilled. Okay, so we can easily get this k by counting the number of unique uh, employees in this given array. Now how to actually assign these numbers? Okay, just, yeah, okay. So basically what we can do is basically we know what are the numbers which we already have, what numbers which we initially have whom we can assign a gift. So basically from 1 to n, these are the numbers. Suppose these are the employees who uh, these are the remaining employees to whom we have to give. So while iterating in this array, at every position we can check if this current person is not already assigned a gift. So we can just assign the same person to this particular I. So such that his wish will get completed. So after we will remove that employee from our remaining employees, and this thing we can do using a hashing or a map, unordered map basically. So for this particular example, if I will run for this particular example, so for employee number one, currently 6 is not assigned, so we are going to assign 6 for this. For employee number two, the 4 is not assigned to anyone, so we are going to assign 4. For employee number three, 6 has already been assigned. So for now, we will mark it something like -1 just to indicate that we need to assign him. So for this person, the two employee number two has not been assigned, so we are going to assign 2. For this, 4 has already been assigned, so we are going to mark -1. For this one, we can assign 5 since he has not been assigned so far. For this last one, 6 has been assigned, so we are going to mark -1. So here these are the all unique pair numbers which were given in our array, and this is going to be equal to k. So now after this first iteration, we have assigned k people with with what they already visit. So after this, now what numbers we are remaining? So basically employee number 1, 3 and 7, we have to assign these employees to among all employees who are left. So all these minuses, we have to fill all these minuses with these remaining employees. So for while again we will iterate in this array, in our array, and whenever we will encounter -1, it simply implies that we have to assign some employee to him. So out among these numbers, we will take the number which is not equal to its index, because the same person could not be assigned to himself. Someone, employee number I, could not be assigned to employee number I himself. So we will check if the index is not equal. So we will assign the number which is not equal to its index. So we can assign 3, suppose. Any random number we will take out of this, and we will check if its index is not equal to the index of employee to whom we are currently assigning. So we will put that. If index is equal, we will take another employee. So by doing this, either we will assign all of them, or we will at the end we will encounter one employee left, such that the out of remaining employees, if only suppose his index is 7, and finally employee number 7 is left. So if we encounter this situation that we have to the employee to whom we have to assign now, his index is equal to what we are remaining with, the employee which we are remaining with. In that case, what we will do, since we cannot assign this 7 to this -1 at this index, we cannot assign 7. So what we will do, we will put the original number, original wish at this position. So before, the wish of the 7th employee was 6, so he was willing to give to employee number 6. So in this case, we will mark this one 6, and we will search the employee to whom we previously assigned 6, and we will replace that with the this remaining employee with 7. So by doing this, since we removed this person's wish, original wish, from 6 to 7, so one fulfilled wish got decreased over here. But here, since we assigned 7 to its original, its previous wish, its actual wish, so one wish got increased over here. So among total k fulfilled wish, the number of fulfilled wishes are not going to decrease by doing this. Okay, so after this these operations, now we will finally have our array, our actual solution array, which we can print. Okay, so let's show you the code so that it become more clear. just a sec. All right, so here we are given n, and then we are given an array. So in A, basically I am storing my original array, which is basically the wish of ith person at ith position, and initially B is basically the copy of A. So what I did, I took one unordered map, okay, and in unordered map, I just kept all unique employees from I equal to 1 to n. So in our unordered map M, currently there are all employees from 1 to n. So we will iterate in our array B. Here I am iterating in our array B, and I am saying if the count of current element bi is basically denoting the wish of ith person right now. So if this bi person is not already assigned, that means he is present in our map. In that case, I'm just erasing him from the map and incrementing our k is basically denoting total number of wish which can be fulfilled, which 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 is basically going to be equal to the size of our sorry, not size of our unordered map, the number of unique terms in A. Okay, so here what we are doing is basically we are if this employee, this bi is not assigned, is not already assigned, so we are basically not changing this bi, and we are just erasing him from our unordered map, which basically denotes that he has been assigned to someone. Now, if particular BI is not present in our unordered map, that means he has been assigned. So we are marking him it with -1. Okay. Now after this, in our unordered map, we all those employees which have not been assigned so far are present, and now we are going to iterate on our array B again, and wherever we will find -1, we will try to put someone from the remaining. Okay, so whenever bi is equal to -1, I'm extracting the very first employee from our unordered map, and I'm erasing him. Now I'm checking if that employee is not equal to the index of the current employee whom we have to assign. So if it's not equal, we are just assigning x to him. Now, if it is equal, then what we are checking, if our unordered map size is greater than 0. If it's greater than 0, that means there are other remaining employees present. So we will take another employee from our unordered map. We will erase him, and we will assign that another employee to our bj. Since all numbers are unique in our unordered map, and x was equal to j plus 1, the index, so y is not going to be equal to j plus 1, so we can easily assign him. And since we didn't assign x, so we are again putting our that x in our unordered map. Okay, in else condition we will come only when the only one employee is remaining, the last employee is remaining, and his current index, what who whichever employee is remaining, it's equal to this j plus 1. So this is the last condition which I discussed. So what in this case, what we will do basically, we will assign this b of j with a of j, which is basically denoting that for jth index, I'm assigning him with his original wish to whom he was willing to give. Okay, so but since a of j we already assigned before to someone else, so we will find in our bj for index which is not equal to j, and it's equal to this ai f basically. So what we will do, we will change his assignment from this a of j to x. X is the current employee, the current remaining employee. Okay, and then we will break. So By doing this, we will finally have our array, the final assigned array, and k is the total number of employees whose wish has been fulfilled. So we will print that k, and then after that we are printing all these bi. Okay, now let's run and see. So this number of what we say, this bi, the number of permutation, or the solution could be like more than one correct solution. So but the total number of fulfilled wish would be same only. So here this first one, you can see two wishes has been fulfilled. For the second one, you can see the four wishes has been fulfilled, which is the correct one only. And for all these, any index is not equal to, like all these numbers are unique, and I some index, some employee is not assigned to himself. So I hope you understood the solution. So all right, thank you guys.